this video, we will see a problem on principal stresses in planes in which there would be stresses in two mutually perpendicular directions accompanied by a shear stress. Here is the question. Now I'll read this question and write the data along with it. Here it is given, at a point in a strained material, there is a tensile stress of 80 megapascal upon a horizontal plane. So the first thing is, in the data, there is tensile stress given of 80 megapascal. So tensile stress, I'll assume it to be in x direction, 80 megapascal tensile. Next, and a compressive stress of 40 megapascal. Now, since it is compressive stress, we have to take it as negative. Upon a vertical plane, full stop, there is also a shear stress of 48 megapascal. Shear stress, I'll denote it by tau. It is 48 megapascal acting upon each of these planes. Determine the planes of maximum shear stress at the point along with its magnitude. Means here in this question, we have to find out the maximum shear stress and its location, which is given by theta 3 and theta 4. So now, with the data available to us, let us try to get the solution to this problem. Now in the solution, I'll draw the diagram first. Now, since they have given 80 megapascal as the stress along x direction and it is of tensile nature, so first I'll denote the tensile stress as 80 Newton per mm square having tensile nature, and there is compressive stress along the vertical axis. Its value is 40 megapascal, that is 40 Newton per mm square. Now, along with these two stresses which are mutually perpendicular to each other, there is even shear stress which is given. So I'll denote the shear stress here. The value of shear stress is 48 megapascal. So 48 Newton per mm square. Now here I am assuming this as clockwise shear because one of the shear stress is acting along this plane towards left hand side. The other shear stress is acting along the plane which is on the right hand side. So because of these two opposite directions of shear stress, there is a clockwise moment produced. So it means your clockwise shear stress would be taken as positive, and if it would have been anti-clockwise, then the shear stress would have been negative. Here in this problem nothing is mentioned, so I am assuming it to be in clockwise direction. Now once we have understood this, in order to calculate the maximum shear stress and its location, we will require the major principal stress and minor principal stress. So first we should start the calculation from that. I'll say that since for stresses acting on a body in two mutually perpendicular directions accompanied by a shear stress. Now for such a condition which is given in the problem where we have two mutually perpendicular stresses and shear stress, the first thing is major principal stress the major principal stress is given by sigma n1 is equal to, it is sigma x plus sigma y by 2 plus root of sigma x minus sigma y by 2 whole square plus it is tau square. Now this is the formula to calculate the major principal stress, and this major principal stress would be used in the calculation of maximum shear stress. Now I'll go on putting the values in this equation. So therefore sigma n1 will be equal to, sigma x is positive so 80 plus sigma y is negative so minus tau is 48 so square. Now if I go on calculating this, my first answer will come out to be sigma n1 is equal to 90.84 Newton per mm square. So this is the major principal stress. Since the answer is positive, I'll say that it is a tensile stress. Next, in a similar manner, I'll write down minor principal stress is given by sigma n2 is equal to the same formula sigma x plus sigma y by 2. Then there is negative sign root of sigma x minus sigma y by 2 whole square plus tau square. So this formula is similar to the one we have seen for major principal stress. Only difference is of, in major principal stress we were having positive sign, here we are having negative sign. Now we will put the values in this formula. Now I'll put the values here. Therefore sigma n2 is equal to sigma x, it was 80 positive, sigma y negative, therefore sigma n2 comes out to be minus 56.84 Newton per mm square. So therefore, since this answer is negative, it means that the nature of the stress is compressive. So here we have minor principal stress as a compressive stress, major principal stress was tensile. Now after this, the next thing is calculation of maximum shear stress. So I'll say that maximum shear stress is given by tau max is equal to plus or minus sigma n1 minus sigma n2 upon 2. This is the formula of maximum shear stress. Putting the values here, sigma n1 we have found out it was 90.84 Newton per mm square minus sigma n2 that was minus 56.84, it was negative so compressive, divide by 2. So therefore tau max value it comes out to be plus or minus 76.84 Newton per mm square. So once we have found out the maximum shear stress, this is the first answer for us. Now, after getting the maximum shear stress, we need to know where it is located. And for that, we should know the location of principal planes. That is on where major stress, that is the major principal stress and minor principal stress are acting. So after this, I'll say that therefore, location of major principal plane is given by. Major principal plane is that plane which carries the major principal stress, which is sigma n1. So here the formula would be tan 2 theta 1 is equal to 2 into tau upon it is sigma x minus sigma y, where theta 1 is the location of the major principal plane. So putting the values here, therefore tan 2 theta 1 is equal to 2 into tau was 48 upon sigma x it was 80 minus sigma y minus 40. So from this I'll get the answer of theta 1, which is 19.33 degree with respect to horizontal. After getting the location of major principal plane, I'll find the location of minor principal plane. Therefore, location of minor principal plane. Minor principal plane is exactly at 90 degree inclined to the major principal plane. Theta 1 19.33 plus 90. So therefore theta 2 it comes out to be 109.33 degree. It is again with respect to horizontal. Now once we have got theta 1 and theta 2, now we can find the location of plane carrying maximum shear stress. So therefore planes of maximum shear are given by the first plane is theta 3 and that is equal to theta 1 plus 45 degree. So this is the relation. Theta 1 was 19.33 degree plus 45 degree. So hence theta 3 comes out to be 64.33 degree. This is the location again with respect to horizontal. So this is the second answer for us. And now theta 4 is theta 2 plus 45 degree. So therefore theta 2 was 109.33 plus 45 degree. So therefore theta 4 comes out to be 154.33 degree with respect to horizontal. So this is the third answer. Now if we look into the problem, the question was to calculate the maximum shear stress and the location of maximum shear stress, that is the location of planes which carry the maximum shear stress. So we have found out all the values. So now once we have found out all the values and the locations, I'll locate all the values on this diagram. That is, I'll show how to mark the stresses. First, I have drawn a horizontal line This represents sigma x. It was tensile. Next, now the first thing which we have found out, it was theta 1, that was the first location of the major principal plane. We have found out theta 1, it was 19.33 with respect to horizontal. First I'll locate theta 1, then theta 2. So here I am taking an arbitrary angle, that is just by a judgment, an angle of 19.33. Now here this angle is having a value of 19.33 degree, and this is my major principal plane. Now this major principal plane will carry the major principal stress, and that was sigma n1. So we have found out sigma n1. Yes, it was 90.84 Newton per mm square. So on this plane there is a major principal stress. I'll denote it as, since it is tensile, so I am denoting it in this order, marking the arrows away, showing tensile stress. So here this plane carries sigma n1 is equal to 90.84 Newton per mm square. This is the major principal stress acting on major principal plane. Now after this there is minor principal plane which carries the minor principal stress, and that was exactly 90 degree to the major principal plane. Now here this angle is 90 and the total angle is 109.33. So this is minor principal plane. Now this minor principal plane will carry sigma n2, and sigma n2 was compressive, having value 56.84 Newton per mm square. So on this minor principal plane I am denoting the stress as compressive. Arrows are pointing towards the plane. The value of stress is, it is 56.84 Newton per mm square. Now after marking the major principal plane, minor principal plane along with the stresses, the next thing is plane of maximum shear, and that is denoted by, the location is theta 3 and theta 4. So theta 3 is inclined at 45 degree to theta 1. Theta 1 was 19.33. So 43 degree, it is inclined at 45 degree to the major principal plane. Now this plane which I have drawn, its angle is 45 degree with respect to the major principal plane. It means this is the plane of maximum shear. So this is maximum shear plane, and the stress value was of maximum shear stress. We have found out tau max, that tau max value was plus or minus 76.84 Newton per mm square. So it is plus or minus 76.84 Newton per mm square. Next, there is another principal plane which is of maximum shear, inclined at 45 degree to the minor principal plane. So here I have the minor principal plane. So inclined at 45 degree to it. Now, so to the minor principal plane inclined at 45 degree, there is another plane of maximum shear stress, and it has a value of tau plus or minus 76.84 Newton per mm square. Now, so here with the location of all the principal stresses and shear stresses, we can say that the problem has been completed.